Let's explore exercise 621. Now you can see it right there on your screen. All right, I'll read this section right in here. It says, John Bowie is trying to determine the amount to set aside so that he will have enough money on hand in 4 years to overhaul the engine on his vintage used car. While there is some uncertainty about the cost of engine overhauls in 4 years, by conducting some research online, John has developed the following estimates. So he's got this probability of what the overhaul cash flow would be, all right? And those should add up to 100%, which they do. Now, they provide us with factor tables, and then here's what we're asked to determine. How much should John Bowie deposit today in account earning 9%? Now, I'm just reading right in here, okay? Compounded annually so that he will have enough money on hand in 4 years to pay for the overhaul. And they give us the factors to use. Now, the solution is 465. Let's see how we get that. Okay, now I've put the solution here in the center of the screen, right? You see my mouse moving around it. So what do? We take the estimated cash flow that they give us and we multiply it times the probability. In fact, let me move this off to the side so you can see. I'm just taking the information over here, listing it here and doing the multiplication. And that gives us an expected cash flow. If we sum that, we have the sum coming out to 100%. So our best point estimate of the expected cash flows is going to be 656. And then we say, well, then we have to figure out what the present value of that is. So we've got to use the present value factor, and it's 4 years from now at the interest rate 9%. Why do we know that? Because he wants to know the cost of, he wants to know what he has to set aside today to pay for that overhaul in 4 years. Okay? And they told us to use 9%. So the factor that they come up with is 0.70843. Okay, so now I've put the interest tables available. The first one is the future value of $1. Now, we're not interested in the future value of $1. We're interested in the present value. So if I slide on down, we get to the present value. We're going to look for 9%. For 4 periods. So if I go to 9% right there, and for 4 periods, and I find where that cross, where they meet, there's our 0.70843. So that's the factor that we should use. Okay, so we multiply the 656 times the 0.70843, and we come up with the 465. All right, now, I'm not a fan of using the table approach. I know that lots of accounting textbooks still teach this approach, but in this day and age, everyone has access to either Excel or Google Sheets or another spreadsheet. So what I tend to do is work it in Excel. So here we've got Excel, and what I would have done, here's the solution here, but my approach was I would have said, well, what's the future value? Well, the future value is 656. Now, I probably would have used Excel also to come up with the 656, but for purposes of this demonstration, we'll just take the 656 and move forward. All right, so I've got $656 as the future value, right? The number of periods they told us is 4. The interest rate is 9%. So I will just calculate the present value. And the easiest way to do this is type equal PV using the present value function, hit the left parenthesis, then come up here to the insert function. You get this nice pop-up window that appears, and then you just start pointing to what each variable is. You're going to need to complete enough variables to do this correctly. So the interest rate is 9%, the number of periods is 4 periods, and the future value is 656. Now, I'm going to make this negative. There is no payment. That's simply the future value, right? There's no stream of payments, so we leave that blank. And now you see I get 464.7, but it matches to 465. If I hit OK, we get that value but it shows up as a negative. Now, why is that? Let me explain that real quickly. Whether you're using a financial calculator, an online calculator, or Excel, the assumption is that inflows are positive numbers and outflows are negative. So if we think the future value is what we're going to get back, then we have to give up present value. We have to give that up now. So the easiest way to make this come out as a positive number, which makes more sense to us, is we are going to say, what are we giving up in the future? How much do we have to save today to give up in the future? So I'll just make B2 negative B2, and then I come up with 464. And of course, if I round that to whole dollars, it matches, and I've got the 465. Okay, so that would be my approach to solving this using Excel.